Let's do a few couple more molarity calculations. Remember, molarity is a measure of concentration in moles per liter. Now, in the case that they give you the moles already and the number in liters already, then it's smooth sailing. You're just plugging in numbers. So if we have, what is the molarity of a solution that is made from 0.9 moles of acetic acid in 0.5 liters of solution? There's your moles, there's your volume. So the molarity is going to equal 0.9 moles of my solute divided by 0.5 liters of solution. So 0.9 divided by 0.5 is 1.8 molar. Now, in the event that they do not give you on your test the moles, but they give you grams, then you just have to do a conversion to moles. So we have this one. What is the molarity of a 0.5 liter solution made with 12 grams of hydrochloric acid? Okay, so hydrochloric acid, chlorine is 35.5, hydrogen is 1, so the GMW is 36.5 grams per mole. Okay, well, if you've got 12 grams of hydrochloric acid, you want to know how many moles you have. You're going to flip it or divide by the 36.5 grams per mole. Okay, so 12 divided by 36.5 is going to give you we're just going to say 0.33 moles. Okay, so molarity is 0.33 moles divided by my 0.5 liters of solution. So 0.33 divided by 0.5, and you get a 0.66 molar solution. Okay, the only other way that they could make this problem difficult for you is if they don't give it to you in liters. But that's easy enough to do. So just remember that if they give you a number like 674 milliliters, move your decimal 3 places, and that equals 0.674 liters. Okay, just divide by 1,000 if you get that. Okay, there's 1,000 milliliters in a liter. You move your decimal point over 3 places. Okay, the other variation that you might see on this type of a problem is when you have a dilution calculation. We see these really often with acids because we want to give you the safest form of an acid possible to work with in the lab, and that's going to be the most dilute acid. So the higher the concentration of an acid or a base, the more caustic or dangerous it would be. So we want to give you a lower solution. So let's say that in our stock room or stock closet that I have, we have a 6 molar hydrochloric acid solution. We need 300 milliliters of a 0.5 molar solution. Okay, so with this calculation, remember we use M1V1 equals M2V2. There are 2 ways that you could screw this up. The first way you could screw it up is that you could not keep track of which one is your 1 and which one is your 2. So this is what I always do. they're going to give you some kind of sentence like, we have 6 molars hydrochloric acid. Okay? We don't know what volume we need. Okay, so we need to know how much of this do we add to our solution. Okay? They do give you this information. They say you have 300 milliliters of a 0.5 molar solution. That's what you need. Okay? So since they gave me this information, it really doesn't matter. As long as your 1 is a 1 and your 2 is a 2, you're good. But since they gave me this information, I'm just going to call it 1, because we need a solution. We need, okay, so I'm going to call this 1. And remember, the 300 milliliters, that's 0.3 liters. Move my decimal over 3 places. So the molarity of number 1 is 0.5 molar. The volume of number 1 is 0.3 liters. I know the molarity of this right here, number 2, but I don't know the volume that I need. So my molarity is 6 molars, but I have no idea what volume to use yet. So 0.5 times 0.3 is going to give me a 1.5. I'm going to divide that by 6. Okay, so 0.3 times 0.5. I'm sorry, that's a 0.15. Y'all, I'm so tired. Okay, so that's 0.15. I'm going to divide it by 6, and that means I need 0.025 0.025 liters of this 6 molar solution. In other words, I need 25 milliliters of it. Okay, so what this means is I'm going to go into my stock room, and I've got this bottle in my stock room that says hydrochloric acid 6 molar, and I'm going to take 25 milliliters of it. Okay, so I'm going to pour 25 milliliters of it into my new bottle, and I'm going to, so I got 25 milliliters of that 6 molar hydrochloric acid, and I'm going to put enough water into my container to make a total of 300 milliliters. And that will give me my 0.5 molar solution that I need. Okay, so all you do on here, it is a very simple problem. You just substitute. The only way that you can make a mistake on this is if you get your like M1 and your V2 combined on the wrong sides. So just, take the moment when you have these two together that says we need 300 milliliters of this solution, put a box around it and say, hey, this is going to be number 1, or this is going to be number 2, whatever. And that way you won't mess that up.